The people of ancient Greece were able to prove that the Earth was round over 2,000 years ago. They also figured out the circumference of the planet by making a few simple observations of the Sun. But why is it so that even though there are uncountable planets, stars, and moons in the known universe, they have the same general shape? No two planets are completely the same. While the Earth may be a perfect oasis for life, nothing else observed so far has even come close to being just as habitable. Other types of planets include gas giants, rocky terrestrial worlds, and even frozen wastelands. The diversity on display ranging from planet to planet is fascinating, but one thing remains constant: they are all round in shape. Stay tuned to find out why. While all planets may appear round to the naked eye, the fact is that they have minor irregularities when inspected up close. Gravity plays a massive role in determining how spherical a planet is. Bigger objects in the universe tend to be rounder than others simply because of the influence of gravitational forces on their surface. The gravitational pull generated by an object has always been observed to point towards the center of its mass. As an object increases in its overall size, so does its gravitational pull. If you've ever wondered why the gravitational pull of the Earth doesn't just swallow us underground towards the core, it is because that pull is opposed by the strength of the solid object itself. The reason why the downward force of gravity does not pull us to the center of the Earth is that the ground pushes back at us when we stand. This push is much stronger than the force of gravity and ensures you don't sink through. Even though the Earth is strong enough to prevent gravity from swallowing you to the depths, it does have its limitations. As an example, let's look at one of the most prominent natural wonders of the Earth, Mount Everest. As the mountain gets taller, its overall weight also increases. Eventually, it will get to a point where the strength of the Earth will no longer be able to hold it to the surface, and the mountain will begin to sink. As the weight of the mountain pushes it further towards the Earth's mantle, its overall height will be affected. That being said, in reality, gravity is not as powerful as you would expect. The size of an object would need to be incredibly massive for it to generate a strong enough gravitational pull to overcome the natural strength of the materials it is made from. This is why smaller objects that are just a few yards or miles in diameter don't have a strong enough gravitational pull to force them into a round shape. To further understand why planets are round, let's briefly talk about the formation of our solar system. The nebular hypothesis is the most commonly accepted model for the formation of stars and planets that we know. It is speculated that our solar system started as a massive cloud consisting of dust and gas drifting across space. A cosmic event some 4.7 billion years ago caused this cloud to collapse. The most common theories for this event are either a passing star or even massive shock waves from a nearby supernova. Whatever it was, it caused a massive gravitational collapse in the cloud. This made the pockets of dust and gas already littered in the cloud combine into a dense formation. As these dense formations started to pull in more matter from their surroundings, the momentum of the process caused them to start rotating and heating up due to pressure. Most of this material came together in a ball to form the Sun, while the rest formed into a disk that started circling it. The constant accumulation of matter on this disk, including gas and dust, gravitated together and formed even larger bodies. Since silicates and metals have a much higher boiling point, only they could withstand the heat of the Sun and remain solid. These solid materials eventually became terrestrial planets: Venus, Mars, Mercury, and the Earth. As for how these massive celestial bodies took on spherical shapes, the answer to that lies in a concept known as hydrostatic equilibrium. When any object is massive enough that its gravitational pull is more powerful than the materials it is made out of, all of its mass will naturally pull inwards into the shape of a sphere. Areas of the object which are too high will be pulled down and displace the objects that were there before. This in turn means that any areas that are too low will be pushed outward. When the object achieves a spherical shape, this process is called reaching a hydrostatic equilibrium. If you're wondering what size an object needs to be to achieve this spherical shape, well, that depends on what the object is made of. For example, an object that is made up of just water would reach a hydrostatic equilibrium quite easily, as water molecules tend to move around freely and have no strength. Conversely, an object that is made up of something like pure iron would need to have incredible mass to have enough gravitational pull to overcome the massive strength in iron molecules. Looking at the solar system, it is estimated that an icy object needs to be at least 248 miles in diameter to become spherical. This threshold increases even more for objects that are made of stronger materials. Mimas, which is one of Saturn's 82 moons and is famous for looking like a Death Star, is only 246 miles in diameter, yet still retains a spherical shape. Currently, it is the smallest object in the observable universe that has met this criterion. The speed at which a planet rotates on its axis also plays a part in its overall shape. When an object spins, its gravitational pull isn't as severe around its equator. The equator is the area that is the halfway point between two poles of a planet. As we travel closer to the poles, the effects of gravity start to become much more prominent. As a result of this process, the generally spherical shape of a planet is slightly altered. The hydrostatic equilibrium shifts to something called an oblate spheroid. This term defines when an object has more width around its equator compared to the poles. Earth also falls under the category of an oblate spheroid. Our planet's diameter on the equator is around 7,926 miles, while its diameter when measured from pole to pole is 7,898 miles. Generally, the faster an object in space spins, the more amplified this effect is. For example, Saturn has density levels lower than water and completes one rotation in around 10 hours. This causes it to be much less spherical compared to the Earth. Some other stars outside of the solar system are even more extreme though. Altair is a very bright star that is often visible in the northern skies of Australia, but only during the winter. It has been observed to complete a spin in around just 9 hours. This incredible speed means its diameter around the equator is at least 25% larger than that between its poles. There you have it, guys. The closer you analyze a question such as this, the more you learn about the universe and the laws of nature. In simple terms, when an object becomes of a certain size, nature shapes it into the most efficient shape there is, and this just happens to be a sphere. And for good reason too. If the Earth was flat, it wouldn't be a habitable place to live. There is no telling how gravity would react in such a scenario. Since gravity pulls everything to one point in the center, flat Earth would mean the farther you get from the center of the planet, the gravitational pull would start to become horizontal. This would cause weird problems like water being sucked towards the center of the planet, and trees and plants would grow diagonally. The Earth constantly revolves around the Sun. This is responsible for day and night cycles, as well as helping the planet sustain life as we know it. If the Earth wasn't round, this rotation wouldn't be possible, as gravity would behave very differently. The Earth would be unable to orbit the Sun and would instead travel in a straight line away from it into the depths of space. This is why it is important to appreciate the special circumstances that came together to ensure we exist. We hope you liked today's video. Please leave us a like and subscribe to the channel for more answers to the curiosities of space. How do you think life would be if we didn't have any gravity? Would it be more fun? Please share your thoughts in the comments below.